Welcome back. In previous lessons, we learned that a PV module produces power which changes whole day and whole year because of the fact that the sun energy is changing whole day and whole year. So how a manufacturer of a PV module specifies the power of a PV module? The data displayed here is taken from a data sheet of a PV module from a manufacturer, the name not displayed here. And these are the electrical data of various PV modules. And you can see on the left side that there are a number of particular parameters like the peak power, which is actually maximum power or the maximum power at power point tracking, and the maximum voltage and the current IVMPP and IMPP, maximum power point and current under the maximum power point, and the open circuit and short circuits and module efficiency. However, you can see that these parameters have different values under different columns. Now, this is the first model, this is the second model of the PV module, this is third model. This is how a PV manufacturer specifies the electrical parameters for various models. But the first model, which is this one, okay, this module has been provided with even more than one column. And the first one is STC, which stands for standard test conditions. And the second one is NOCT, okay, which stands for normal operating cell temperature, and BNPI basically for the bifacial module, because this module is bifacial. So bifacial nameplate irradiance is the standard used here. Now let's see what is the STC. Okay, STC stands for standard test conditions and is defined over here. You can see STC here. And what are the test conditions? The test condition says that the module was tested under irradiance of 1000 watt per meter square, and the cell temperature was kept at 25 degrees centigrade, and air mass was 1.5. Air mass refers to the sun path length from the sun to the earth crust, and if the shortest length is 1, then the sun path taken was 1.5 times the shortest length. That is the standard testing conditions under which the module was tested, and the peak power produced by the module was 490 watts. Okay, now this means if the cell temperature increases, okay, the module was tested under the cell temperature 25 degrees centigrade, or the cell temperature was kept 25 degrees centigrade by controlling the ambient temperature where the module was tested. And if the cell temperature increases, in reality, the cell temperature will increase, because if the ambient temperature is, for example, 20 degrees centigrade, okay, which is average ambient temperature that can be considered around the world for a day or for a whole year, then the cell temperature will be definitely higher than this. So the cell temperature is normally like 15 to 30 degrees centigrade higher than 20 degrees centigrade, and that means the cell temperature of that PV module could be like 40 to 50 degrees centigrade. Okay, now in that case we can't use the STC. Okay, so STC is a nominal standard which is used by the manufacturers to specify the power, and the next standard is NOCT. Okay, what is NOCT? Under NOCT, in NOCT the irradiance taken is 800 watt per meter square. Okay, and the ambient temperature is considered here, not the cell temperature. So the ambient temperature considered here 50 degrees centigrade. Okay, now this is more realistic, and we can say that the average sun energy or the irradiance around the world at a particular location can be taken as 800 watt per meter square, and the ambient temperature, if taken 20 degrees centigrade, then the power produced by the same module is 375 watts reported by the manufacturer. Okay, now it's the same module. Under STC, it produces 490 watts, but under NOCT conditions, it produces 375. So the point here is that the same PV module, if given different conditions, will produce different power. Similarly, the other parameters are also changing. Okay, you can see here that the maximum power voltage, the maximum power current, open circuit voltage, short circuit current, and module efficiency, they are specified for STC and NOCT separately. Now, if you see the module efficiency, which is 22%, okay, what this means and why it is same for both STC, NOCT, and the third one, BNPI. Because the module efficiency is same, Under various conditions, the module will behave in terms of the efficiency in the same manner. The condition changes, the power produced by the PV module changes, but the efficiency remains the same. Now, how efficiency relates to the peak power, we will see in one of the next lessons, that how we can translate the efficiency into peak power, or how translate peak power into efficiency in the coming lessons. One thing which is important to be noted is that if the power being produced by the module is 490 watts under STC condition, and this is not the energy unit, remember. That means if the 490 watts are being produced by a PV module, then if these 490 watts are being continuously produced for 1 hour, okay, if this is 1 hour duration, then you can translate this into energy units. And how much energy units will be in 1 hour? Very simple, divide 490 by 1000, and this comes out to be 0.49 kilowatt hour. Okay, so if this module is run under STC condition for 1 hour, we will have 0.49 kilowatt hour of energy or energy units being produced. How about if the same module is run for 2 hours? Then the total energy units being produced are, simply take 490 divided by 1000. This becomes 0.49 kilowatt, and multiplied with 2. So this is 0.98 kilowatt hours, or roughly it is 1 energy unit. Okay, so if this module is run for 2 hours, it will produce approximately 1 energy unit. But the condition is that the cell temperature must remain 25 degrees centigrade. The energy being received from the sun must be 1000 watt per meter square. Remember, per meter square. Okay, if the area of the module is like 1 by 2 meters, suppose it is 1 and it is 2, then the total area will be 2 meters square, right? So the total sun energy which must be received by the module should be 1000 into 2, that is 2000 watts, okay, as per STC conditions. So for this particular module, 2000 watts is received by the module, and the cell temperature remains 25 degrees centigrade, and the air mass is 1.5. Then for 2 hours, this module shall produce 1 energy unit.